We think we know the universe. We see the brilliant glow of stars, the majestic spiral of galaxies, the familiar comfort of our own planetary home. We've built incredible tools to peer into the farthest reaches of space, mapping the cosmos with breathtaking detail. But what if I told you that everything we can see, everything we've ever detected or touched, all the stars, planets, and galaxies combined, makes up less than 5% of reality? The other 95% is invisible, unknown, and yet it dictates the very structure and destiny of our universe. Welcome to the greatest mystery in all of cosmology: dark matter and dark energy. For centuries, our understanding of the universe was built on what we could observe. From the first stargazers to the powerful eyes of the Hubble and James Webb Space Telescopes, we have painted a magnificent portrait of the cosmos. We see vibrant nebulae where new stars are born, immense clusters of galaxies bound together by gravity, and the faint, ancient light from the dawn of time. This is the universe of ordinary matter, the stuff made of atoms, the building blocks of you, me, and everything we have ever known. But this familiar world, the one we so proudly chart and explore, is merely a sliver of the whole. The standard model of cosmology, our best map of reality, tells us that this ordinary matter accounts for only about 5% of the total mass and energy in the universe. The rest is a profound enigma, a cosmic shadow that we call the dark universe. So, what is this invisible 95%? Let's start with the larger of the two mysteries. Dark matter. It makes up about 27% of the cosmos. We can't see it. It doesn't emit light or energy, but we know it's there because we can see its effects. Imagine the universe as a grand, cosmic web. The glowing galaxies we see are like cities of light, but they are all connected and embedded within a vast, invisible scaffolding. This scaffold is made of dark matter. Its immense gravitational pull is what drew the first gases together to form stars and galaxies. Without dark matter, the structures we see in the universe today simply wouldn't exist. The first major clue came from the way galaxies spin. In the 1970s, astronomer Vera Rubin observed that stars on the outer edges of galaxies were moving just as fast as stars near the center. This defied Newton's laws of gravity. Based on the visible matter alone, those outer stars should have been moving much slower, or they should have been flung off into space. The only explanation was that there had to be a huge amount of unseen mass, a halo of invisible matter surrounding the galaxy, providing the extra gravitational glue needed to hold it all together. This was the first strong evidence for dark matter. Further proof came from a spectacular cosmic event known as the Bullet Cluster. This is actually two galaxy clusters that have passed through each other. When they collided, the hot gas of normal matter from each cluster smashed together, slowed down, and created a shockwave. But observations of gravitational lensing, way mass bends the light from background objects, showed that most of the mass from the clusters passed right through the collision without slowing down at all. The dark matter, it seemed, had separated from the normal matter. It interacts with gravity, but not with any other force, not even with itself. It is a ghost in the cosmic machine. For decades, physicists have been on a relentless hunt to find the particle responsible for dark matter. They've proposed candidates like WIMP's weakly interacting massive particle Zandax. They've built incredibly sensitive detectors, deep underground, shielded from cosmic rays, hoping to catch a rare, fleeting glimpse of a dark matter particle bumping into an atom. But so far, after years of searching, they have found nothing. Dark matter holds the universe together. It dictates the architecture of the cosmos, yet we have never directly detected a single particle of it. It remains one of the most stubborn and humbling puzzles in modern science. But the mystery doesn't end there. If dark matter is the invisible glue holding the universe together, there's another, even more dominant force trying to tear it apart. This is dark energy. It makes up the remaining 68% of the universe. To understand it, we must go back to the beginning. We know the universe began with the Big Bang and has been expanding ever since. For a long time, astronomers thought this expansion must be slowing down, pulled back by the gravity of all the matter within it. They expected to find that the universe's expansion was decelerating. But in 1998, two independent teams of astronomers studying distant supernova exploding stars that serve as cosmic lighthouses made a shocking discovery. The supernova they observed were dimmer, and therefore farther away than they should have been. The only way to explain this was if the expansion of the universe was unslowing down at all. In fact, It was speeding up. Something was pushing space itself apart, accelerating the expansion at an ever-increasing rate. This mysterious anti-gravitational force was named dark energy. It acts like a pressure embedded in the fabric of space-time itself. The more space there is, the more of this energy there is, and the faster space expands. It's a runaway process. Unlike gravity, which pulls things together, dark energy pushes everything apart. So, what could it be? One idea is that it's a property of empty space itself, what Einstein called the cosmological constant. He originally added it to his equations to create a static universe, calling it his biggest blunder when he learned the universe was expanding. Ironically, he may have been right for the wrong reason. Another possibility is a new kind of dynamic energy field, dubbed quintessence, that changes over time. But when physicists try to calculate the amount of this energy from our understanding of quantum mechanics, the energy of the vacuum, the number they get is astoundingly wrong. It's about 120 orders of magnitude larger than what we observe. This has been called the worst theoretical prediction in the history of physics. It tells us we are missing something fundamental in our understanding of the universe. The existence of dark energy not only governs the present-day acceleration, but also seals the ultimate fate of our cosmos. It points towards a future known as the Big Freeze, or heat death, where galaxies will accelerate away from each other so fast that they will eventually disappear beyond the cosmic horizon, leaving our own galaxy an isolated island in an endless, empty void. Now, the universe has other profound mysteries. Of course, there are black holes, points of infinite density where the laws of physics break down, surrounded by an event horizon from which not even light can escape. What happens inside a singularity is one of the deepest questions in physics. And then there is quantum entanglement, what Einstein called spooky action at a distance, where two particles can be linked in such a way that they instantly affect each other, no matter how far apart they are. These phenomena challenge our very notions of space, time, and reality. But while fascinating, these mysteries pale in comparison to the sheer scale of the dark sector. Dark matter and dark energy are not isolated oddities. Together, they dominate the entire cosmos, making up 95% of everything that exists. Dark matter and dark energy aren't just gaps in our knowledge, they define the structure, the evolution, and the ultimate fate of everything. They are the invisible architects and the silent drivers of our cosmic story. We look out at the night sky, at the familiar patterns of stars, and the milky ribbon of our galaxy, and we feel a sense of connection to this vast expanse. But we are only seeing a faint glimmer of the true reality. The most mysterious thing in the universe is a distant object, or a strange phenomenon out there somewhere. It is the universe itself, and 95% of it remains a profound, dark, and beautiful mystery, waiting to be discovered. Thank you for watching. If you're fascinated by the great mysteries of our universe, be sure to subscribe for more journeys into the unknown.